Neural networks. Neural networks are a complex system of algorithms that are modeled after the human brain. They are used in a variety of applications such as image recognition, speech recognition, natural language processing, which means that neural networks are a sophisticated collection of algorithms that mimic the functioning of the human brain. They are utilized in numerous applications, which are image recognition, speech recognition, and language processing. Neurons. The neuron is the building block of neural network. It receives input from other neurons, processes that input, and then sends an output to other neurons. Neurons are connected to the layers to form a neural network. The neural network's fundamental unit is the neuron. Other neurons provide it with the input. It analyzes that input and then sends it to another. It sends output to another neurons. A neural network is made up of layers of neurons connected to one another. Types of neural networks. There are two types of neural network. One is artificial neural network. The other one is convolutional neural network. Let's see artificial neural network first. Artificial neural network is usually a computational network based on biological neural network that construct the structure of the human brain. Similar to a human brain has neurons interconnected to each other, artificial neural network also have neurons that are linked to each other in various layers of the networks. These neurons are known as nodes, which means that biological neural network that build the structure of the human brain serve as the foundation for artificial neural network. Artificial neural network are often computer networks. Artificial neural network also feature neurons that are linked to each other in different layers of the networks, just as neurons in a real brain. Nodes are the name for these neurons. In this diagram, x1, x2, xn are the input signals which are sent by the programmer, and w1, w2, wn are the weights of the neurons which are interconnected to each other, and it is sent to the neurons. This neuron, there are two parts. One is summation, the other one is activation. In summation part, the input signal is multiplied with the corresponding weight and its sum is taken. After the sum is taken, it is added with the bias and then is set to the activation part. In the activation, the corresponding activation function is applied and processed, then it is sent as output signal as y. Now let's see the activation function detail. The activation function determines whether a neuron should be activated or not based on the input it receives. Common activation function include sigmoid, ReLU, and TAN. The choice of activation function can have a significant impact on the performance of the neural network. It determines weighted total is passed as input to an activation function to produce the output. Activation function choose whether a node should fire or not. Only those who have fired make it to the output layer. There are distinctive activation function which are activation function that can be applied based on the sort of task we are performed, which means that based on the input it receives, the activation function determines whether or not a neuron should be activated. Sigmoid regard than are frequently used activation functions. The neural network's performance can be significantly impacted by the activation function that is selected. The output is produced by passing the weighted total as an input to an activation function. A node's firing status is determined by the activation function. The output layer is only reached by the individuals who have been fired. Depending on the type of task we are completing, different activation functions are accessible. Now let's see the architecture of ANN. An ANN is composed of neurons which are connected by synapses. Each neuron receives input from other neurons and produces an output that is sent to other neurons. The strength of the connection between neurons can be adjusted through a process called training, which allows the ANN to learn from examples, which means that neurons that make up an artificial neural network are linked together by synapses. Each neuron takes information from other neurons as input and sends that information back to those other neurons as an output. As the artificial neural network learns from examples, the strength of the connection between neurons can be modified through a process known as training. Artificial neural network consists of three layers, which are input layer, hidden layer, output layer. Input layer. As the name suggests, it accesses inputs in several different formats provided by the programmer. Input layer is the layer which accesses inputs provided by the programmer. Hidden layer. The hidden layer presents in between input and output layer. It performs all the calculation to find hidden features and patterns. Hidden layer lies between an input layer and output layer. It performs the calculation to find hidden features and patterns from the input signal that is sent by this input layer. Output layer. The input goes through a series of transformation using the hidden layer, which finally results in output that is conveyed using this layer. The output layer is the layer responsible for conveying the output. The input which is sent by the input layer is undergoes series of transformation hidden layer. After undergoing series, it is sent to the output layer. And in the output layer, responsibility is to send the is to convey the output. Now let's see how does an artificial neural network work. In artificial neural network, the input layer data is fed into the first layer of the network. That is, in the input layer, the input is provided by the programmer. Hidden layer. In hidden layer, I process through multiple hidden layer where it is weighed and transformed. Output layer. The final hidden layer that performs uh, that feeds the output to the output layer, which generates the final output. Now let's see the types of artificial neural network. There are two types of artificial neural network. One is feed forward, the other one is feed backward. Feed forward. Information flow is unidirectional. Unit sends information to other unit from which it does not receive any information. There are no feedback loops. They are used in pattern generation or recognition or classification. They have fixed inputs and outputs. In feed forward, information flows in one direction and it can send information to the unit, but it does not receive any information. And there is no feedback loops present. They are used in pattern generation or recognition or classification. They also have fixed input and output. This is the diagram which shows the feed forward artificial neural network. The next type of artificial neural network is feed backward. In feed backward, information flows in different direction. A unit sends information to other unit from which it does not receive any information. There are feedback loops. They are used in pattern text translation, natural language processing, language translation, sentiment learning. In feed backward, information flows in different direction and it sends information to other unit but does not receive any information. And feed for backward, feedback loops are present. It is used in pattern text translation, natural language processing, language translation, and sentiment analysis. This is the diagram which represents the feedback word ANN. The second type of neural network is convolutional neural network. Convolutional neural networks are powerful machine learning models widely used in image and video recognition. They are capable of processing large amounts of data and detecting complex features in images. The convolutional neural networks are also called as convs and nothing but neural networks sharing their parameters. Which is that convolutional neural networks are robust machine learning models that are frequently employed in image and video recognition. They are able to digest a lot of data and recognize intricate details in photos. Convolutional neural networks are also known as convs, which are nothing more than neural networks than that share parameters. So let's see the architecture of CNN. The first layer in CNN is convolutional layer. The convolutional layer is the building block of a CNN. It performs a mathematical operation called the convolution in the input to image using a set of learnable filters. The output of the layer is a set of feature maps or activation maps that highlight important features in the image, which means that the foundation of a CNN is the convolution layer. The input image is subjected to in convolution, which is a mathematical operation employing a collection of trainable filters. This layer produces a number of feature maps or activation maps that draw attention to significant aspects of the image. The second layer in the CNN is pooling layer. The pooling layer is used to reduce the spatial size of the feature maps and the number of parameters in the model. It works by downsampling the feature maps using operations such as max pooling or average pooling. This helps to reduce overfitting and improve the generalization of the model, which means that the feature map spatial extent and the number of model parameters are both decreased by using the pooling layer. It functions by applying techniques like max pooling or average pooling to downsample the feature maps. This enhances the generalization of the model and lessens overfitting. The third layer in the CNN is relay layer. It is specially used to apply an activation function element wise like as max of 0 is thresholding at 0. It results in 32 by 32 by 12, which results in unchanged size of the volume, which means that it is especially employed to apply an element by element activation function, such as a max of 0 by x thresholding at 0. It yields 32 by 32 by 12 matrix, which pertains to the volumes size remaining constant. The fourth layer in CNN is input layer. If the image consists of 32 bits, 32 height, encompassing 3 RGB channels, which is red, green, blue channels, then it will hold the raw pixel 32 by 32 by 3 values of an image, which means the raw pixel values of an image are stored in an image that has 32 widths and 32 heights and 3 RG and B channels, which is red, green, blue channels. Now let's see how does a convolutional neural network work. I already told you that the first layer is a convolution layer. In convolution layer, the input image is processed through a series of convolution layers, and which apply feature maps and filters to extract key features. And it is sent to the pooling layer. That is the second layer. The pooling layer, the pooled out is then passed through a pooling layer, which reduces the sample size and preserves the spatial relationship between the features. And then it is finally sent to the fully content layer. The fully content layer is the final layer of the CNN, which produces the output. Now let's see the working of CNN. If we pass a matrix of dimension h by w by t and a filter fh by fw by fd is applied, it produces a output volume division, which is h, whose dimension is h minus fh plus n by w minus fw plus 1 by 1. And the matrix of an RGB, the array of an RGB matrix is 6 by 6 by 3. Now consider image pixel whose size is 5 by 5 and whose values are 0 and 1. And when we apply a filter matrix of 3 by 3 as shown in the below picture, it produces an output matrix whose dimension is 3 by 3. This is the image matrix and this is the convolved feature. This shows the operations which can be applied on a image matrix. When we apply an identity matrix, it applies the filter like this and it produces a convolved image like this. And in edge detection operation, we can apply three types of filter and it produces a convolved image, three types of convolved images. And if we apply sharpen operation, it applies a filter like this and it produces convolved image like this one. And there is two more operation, box blur, which is a normalized one, and in that identity matrix is all the values in the matrix are 1 and it is multiplied by 1 by 9 and it produces a blurred image of the blurred image. Gaussian blur, it is an approximation of the blur. In that, if we apply this is the filter of Gaussian blur, when we apply to the original image, it produces a convolved image like this. Now let's see the applications of ANN and the CNN. Here we are comparing the applications of ANN with the CNN. ANN is used in speech recognition, image classification, fraud detection, recommendation system, and financial forecasting. CNN is more commonly used in image recognition, autonomous vehicles, face recognition, medical image analysis, and object detection. Backpropagation. Backpropagation is an algorithm used to train neural network. It works by propagating the error from the output layer back through the network and adjusting the weights of the neurons based on that error. This process is repeated until the neural network learns to accurately predict the output. That is, an algorithm used to train neural network is backpropagation. It operates by returning errors from the output layer to the network and changing the weights of the neurons in response to those errors. Up until the neural network masters precise output prediction, this process is repeated. Conclusion. Neural networks are a powerful tool for solving complex problems. By understanding the building blocks of neural networks, such as neurons, activation function, and backpropagation, we can better design and train neural networks that accurately predict the output. Diagrams are a useful tool for visualizing this complex system. That is, neural networks are an effective technique for resolving challenging issues. We can better create and train neural networks that correctly focus the output if we have a better grasp of the neural network's fundamental components such as neurons, activation functions, and backpropagation. Diagrams are a helpful visual aid for illustrating these intricate systems. Thank you.